So this is component tester number 3. It's the only one that worked. This is one of the little leads that came with it. There are 3. I'm going to stick a lead in terminal 1 and a lead in terminal 3. I'm going to test some Zener diodes, but they require connection to an A and a K. So I have what's marked as a 1 millihenry inductor. I have no idea what, well, they have a silver tolerance ring on them. I don't know if you can see that. The test says it's a 0.99 nanohenry, and it has a resistance of 11.8 ohms. So that's better accuracy than I can get with almost anything else. We have some more 1 millihenries in here that are a little wound. Give you another look at these 1 millihenry guys. Black, brown, green. You can see maybe that also reads 0.99 and 45 ohms resistance. For some reason I wrote 2%. I don't know why. Fairly dingy looking. It apparently just reads 0.34 ohms, and it calls these resistors. So this should be a very accurate 250 ohm resistor. Now, I wouldn't be surprised if we see a little bit higher than 250 ohms, considering resistance of connections. Come on. So I wouldn't be surprised, as I say, it's a half an ohm high. Reached 250.5. Which is extremely good. I was very interested to see how it was going to handle Zener, 3.6 volt. Now I'm going to test it as if it were an unknown component. The meter assumes that there's two diodes in parallel. Well, before I move it to the dedicated Zener diode test terminals, test a 12 volt Zener diode. Now this will surely just show itself to be a diode. And it does assume it's a single diode. After all, it's a 12 volt Zener, and the test voltage is only 3.7 volts. So we'll move the leads to the dedicated K and A terminal. And there we go. Zener, but it doesn't tell me it's a 12 volt. With it connected the right way, you see I had it connected backwards. It identifies it as a 12 volt. So it's a 12.9 volt diode. It must contain, as I would suspect, a voltage booster, probably up to around 30 volts. And it ramps the voltage up until it breaks over. Other testers with a 9 volt battery will not. I've never successfully tested a 12 volt Zener. So we'll try a 27 volts. Okay, I must have it hooked up backwards. Alright, 25.6 volts, if you can read it. See, I can't tell if you're able to read this or not. But just for to see what happens here, I'll go across it with my bench meter. And I'm reading 25.82. Well, 25.82 on the bench meter and 25.6 on this little box. I'd say that's really good. And we'll go back to our 3.6 volts. And it tells me it's a Zener at what, 3.1 volts. Take a look at it with the bench meter. The bench meter reads 3.1225, 3.1 here. Now these are probably a penny a piece. I use Google and I put in, I think, tester TC1 manual. And the first Google hit was this. It doesn't appear to be written in Chinglish. Okay, so automatic detection of Zener diode. Well, that's only true if you're in the Zener diode A and K position. In all the rest of a tester, it just says a Zener diode is a diode. It has an IR decoder. I don't have a remote control with me. And I don't know if Hitachi is a standard in IR decoding, but that's the little IR receiver. Out of this is one thing that says auto power off time settable. However, here's a little better instructions for the short test. It says short all three probes, press the multifunction key, and the tester will automatically calibrate itself. Well, okay. I'm going to say when they say all three probes, they mean plugged into one so with the leads in terminals 1, 2, and 3, I'll just short them together using a short piece of wire. Actually, I'm holding an electrolytic in my hand, but I'm going to put all three of them on one lead. And according to this, it'll enter the self-test mode. Alright. There's a little timing bar there. Then it says, it shows a little picture of the window. Oh, now it says please isolate probes at the bottom. So I'll just isolate them. So it is proceeding self-test. What's some more? What may it ask us to do next? It just tells us to wait until the bar goes to 100%. And in this case, we get the version, which is the V2.12K. Okay, here we go with the power off. Automatic shutdown time is factory set, and it can be set for 10 seconds, 15 seconds, 20 seconds. Apparently by jumping P1 and P2 on the circuit board. This is a DMMCheck by voltagestandard.com. And in addition, well, a DMMCheck. So it provides standard voltage, a standard current signal, and some precision resistors. Voltage signals here. I'm not sure this is still available. It was very inexpensive. There's a 9-volt battery in the back, which may or may not still work. No, it still works. It came with a certificate of calibration. You can see I received this, or at least was calibrated just before I received it, January 25th, 2014. So you see it's 6 years old. And here are the values measured for the precision resistors. And it may have been replaced with a later model. So let's take a look at these standard resistors. Okay, here's 1,000 ohms. And it says 1,006 ohms. We'll go to the 10K resistor. This doesn't really need to be turned on. In order to use the resistors. It says 10.19K, and we'll go to the 100K. Here's the 100K. Reads 99.68K. The resistance readings are really pretty accurate. A standalone just resistance standard is pretty easy to make, and pretty inexpensive if you don't try to hit standard values like 100K, 10K. Look for precision resistors or even precision resistor assortment on eBay, and you may find some 0.05 or some 0.005 resistors, but odd values, and because of that they'll be very inexpensive. But you're not making voltage divider or something that requires a specific resistance or a specific ratio of resistors. Here they're 10:1, but put them in a little box with the two banana plugs on it, or two. Here they just soldered them to a circuit board. I'm sorry, a series. Well, I've never checked that. Mark them prominently so you know what they're supposed to be. And they're you can make a standard pretty cheaply. Don't try to make a standard below, say, 1,000 ohms. If you try to build a 1 ohm standard, you better have a 4-wire device to measure that 1 ohm. Lead resistance and connection resistance, if you're using alligator clips, or can introduce significant inaccuracy in trying to measure a low value resistor. 10K or above, certainly 100K, provides all the accuracy and reading that you need as a hobbyist. And just for the hell of it, we'll see if they're connected in series. So this should read 11K. And you see it reads 11.25K. Very handy little gadget if you just, I think it was only around, I'm sure it was less than $20. Well, I hope you've enjoyed this little run through the tester. If you did, give me a thumbs up. I appreciate it. Like me, or drop me a comment if you have a question. Thank you.